All right, hello everybody. Welcome back. It's a new day. I have a little more energy now. It's basically goals for today. Continue to refine the bearing model, clean up the UI a little bit more, and go through and break things out into predicates and functions as appropriate. So I did a little more thinking yesterday about how exactly I want this entire feature to work and everything. And so I'm realizing I'm going to need to make some more updates to my bearing holes. So I'm actually going to go ahead and make a feature, just a little dummy feature here to print my bearing holes, just so I don't have to keep going back and forth or like keep editing code in my main feature. And the other thing I realized is I don't actually want to support wall type or like wall selections. And the reason why I don't is because I don't think it makes sense in the context of having the main bearing hat. Because basically it doesn't make sense in the context of the main bearing hat, because the problem is if I allow the wall type for the outer features, then like what's the wall of the bearing hole itself, right? So then I would need to like fork that probably to support like both of those options, and it's just too much. And I think it's easier just to be a little more opinionated and just like use standard numbers. And if people have a problem with that, we can always look at adding it later. But I think it's easier just to start out with the bare bones and work on that later if necessary. And so with that in mind, so we do need to update, we need to add some actual dimensions. And so for that I have an actual CAD from the vendor. But basically, I'm just going to be adding some dimensions to the bore selection. So that'll be this node here, right? That way, when the user fills it out, we actually have all the information we need. And so for this, it probably makes sense. Let's see here. Okay, I guess we can do this. Right, so this is just a map, so I can sub it out like this, right? And then I'll do const large bore value, right? And then we can just use this and this, right? And then I can just copy paste this here and this here, right? So a little bit of code reuse here that we benefit from. And then I'm going to basically grab some parameters. So I need to set the outer wall thickness will always be the same, right? But I do need to set like this outer diameter probably, because that will change. So this here is this, which is times 2, so our outer diameter is going to be something there. Right, and this will be a string value, 1.375 times inch. Right, our inner diameter will be and then this inner diameter will be 1.125 inches. Okay. And actually, yeah, do I still need the bore size? What am I using bore size for? Let's check. Bore size. Oh, if we're just getting settings, then we don't actually need bore size. And we can just use the values directly. So Let's do that. So rather than having the bore size, I'll just put all the parameters I need here that are specific to one or another. And then that way, there's no need to like actually differentiate the logic or anything like that. Yeah. So this is what happens when you write features that are tired, when you're tired, basically. Yeah, so here we have the drawing. So inner diameter will be 0.825, 1.25. The counter bore will just be an eighth greater than that. That's fine. And then D will be, what is D here? D is the overall width. We don't, oh yeah, and then D will be 1.125 or 1.375. And technically these are all additions to the main diameter, so we could just do that. And maybe we will actually. Are they all constant? Plus 0.125, plus 0.125, plus 0.25, plus 0.25. Yeah. Okay, and C is that, which doesn't matter. Okay, maybe we'll do that then. So I'll just do my bore diameter. Right, and so this will be 0.865 times inch. Right, and this will be 1.125 times inch. Right. Okay. And then we still, yeah, okay, and then I'll go ahead and generate the table again. And Onshape is not having a good time because I did delete that enum. So I guess I'll bring it back just for now. Okay, cool. And then I need my new feature. What did I name it? Bearing hat table gen? Oh, oops. Okay, this should technically be lowercase, I guess, for correctness. Okay, grab that. Really? Okay, Onshape is struggling. Let's try refreshing. Okay. Weird. Okay. There we go. Bearing hat, table gen utility. There we go. There's our code. Grab that. Okay, so we'll grab this. Paste it in there. Right, don't need bore size anymore. Yeah. Okay, so now what I'm going to do is I'm going to write a function to get the other numbers we talked about, right? So the way you define functions, right? Very well. Yeah, so we'll call this get bore definition. Get bore values, maybe. It will return a map, right? And then the value will be and now I'm realizing that if I do want to do conditionals, I do need to actually have the bore size. So that's embarrassing. Okay, so let's undo a little bit. Okay. Yeah, we'll bring that back. Okay, fine. We'll undo in here as well. We can't. Okay, fine. What did I call that? Bore? Okay. That is so sad. Okay, bore size dot 0.875. Okay, so basically the reason, okay, so I'm all over the place. Okay, so the reason I do want to have the bore size, right? I do actually need it, right? Bore size, right, returns a map, right, is because anytime I do conditional logic, it feels really goofy to do something like, you know, bore equals like 1.125 times inch, right? And the reason why I really don't like doing that is because this looks like an error, right? Because you shouldn't really be using equals with value with units. You should be using tolerant equals instead. And it's not clear that, you know, like the radius here is like a set of discrete values that we're explicitly deciding to handle. Whereas this makes it very clear, like, hey, these are the values we're going to support, and, you know, everything else is going to be kind of wrong, right? So we'll say inside radius, inside diameter. Okay, so the bore diameter will be 0.75 times inch. So instead I'll do a mapping like this, right? If we go back, right? Actually, I'm just gonna cheat and put this on my second monitor, so that way I have it. So we have our bore diameter, and then we have our outer diameter, which will be 1 times inch, right? And then we'll have our outer diameter is 1.125. 1.125, and then our B, yeah, I guess I'll just put them all in here. I may as well. Oh, okay. Yeah. We'll do it like this. I guess I realized I could have just defined it generically. So like if bore diameter was our input, so then you could do this, right? Bore diameter is obviously bore diameter. And then our outer diameter is going to be bore diameter plus 0.25 times inch. And then our this is just going to be a 1/16 of an inch. And I guess I'll do like this for posterity. Yeah. So I guess I could have just done that, but that's okay. Yeah, so 0.875, 1.125. Let's see here, 1.125, and then width, outer diameter is plus 1/4, and then seaboard diameter is plus 1/8, and the depth is a 1/16. Okay, so yeah, so we'll just do this. And so I could have just taken the bore diameter as a parameter here and returned that map. And that would also be equivalent. But, I don't know. I guess it's good having a bore size to say we explicitly support these bore sizes. So, fine. All same difference. It's better to be decisive than to go back and forth about it, which is obviously not my strong suit. But, okay, so there's the bore, and then we'll say, get bore values equals bore. Alright, so we don't even need the bore necessarily now. Table.bore, please. Okay, cool. Right, and so now when we do this, let's see here. So, yep, so here we have bore dot, and this hole will be the outer diameter. So, outer diameter. And then this one will also be, wait, what is that? This is our mounting diameter. Wait. Yeah, this is the outer diameter, and then this is the outer diameter of the plate. And so currently I'm just going to use, oh, they don't actually label that dimension. That's funny. So if I have the CAD here, right, so they're using 0.25, so I'll use that too as well, because it's easiest. Yeah. That's radius. Cool. So we'll just do it like that. So if we look at this again, right, okay, we have an error. What fun. Oh. Okay, so I'll just use the switch statement instead, instead of the ternary, just because this is a little more syntactically concise. Let's see here. Really? Right, so dereference non-container is you're attempting to access something that is not a container using container access notation. So that would be like your brackets for like accessing an array, or your dot to like access a map, right? If you're doing that incorrectly. This looks too small. That is because I was already measuring the radius, so I don't need that divide 2 there, which is going to be this guy here. It's already the radius. Okay, cool. Ta-da. Okay, neat. And now that I think about this a little bit more, I've realized I haven't been making my holes robustly. Have I? No. Yeah, so when I loop like this, right, my mounting locations aren't robust. And so this is a good example of what happens, or why like robustness and disambiguation matters, right? So let's just do this. Let's see here. Okay, so I'll give this as an example. This is useful. So I have my mounting locations, right? And so I've selected 1, 2, right? And so I'll go ahead and add a mate connector now, right? Pretending like these are just mate connectors, but this could be a screw you're assembling to this hole, or something you're fastening this hole in the assembly, or maybe you're sketching and you're drawing a line to these holes later on or something, right? And so I sketched, right? So I selected 1, 2, and I selected it, right? So the question is, what happens when I delete this first mounting hole, right? And so we'll do that, right? And so, and actually, does this work? No, so yeah, so if we go back, right? So this mate connector is on this hole, right? And this mate connector is on this hole, right? So when I delete this one, I expect the mate connector on this hole, mate connector 1, to break, right? But we see when I do that, right, actually what's happened is mate connector 1 is actually fine, right? But it's now over here, right? And mate connector 2 is the one that broke, right? So if we had something mated to this hole, when we delete that hole, right, it would have jumped over here, right? Or it did jump over here, right? And whatever we had mated to this hole is now broken, right? And if we are like, oh, it's broken, that's weird, right? And we add it back, right? Now we're back, right? But you'll see the order has reversed, right? So mate connector 1 is now over here, and mate connector 2 is now over here, right? So we've actually shimmy shuffled these two mate connectors around just by editing our selection, right? And the reason they shimmy shuffled is because these queries, right, it's just going in order. And so when we reverse the order of these queries, then the order of the mate connectors also reverses, right? So if I delete these and I select them back in the original order again, right? Now we're back in business again, right? But now, now we've reversed again, and so now we're back to the original, right? But you can see how this behavior is pretty awful, right? Obviously that's not what we want. And so that's the downside of iterating like this, right? Is we're not doing it robustly, and so those identities will just be tied to the order. And so the way you fix that is you do the same thing that this is doing, right? Where we're creating a sketch for every one, and then we're tying the creation of that sketch using the ID components, unstable ID components, to the underlying entity the user has selected, right? And actually, that's not even necessarily the best thing, right? Because even if you go ahead and tie it, right, then what happens is when you delete this, right, instead of mate connector 1 jumping over and mate connector 2, or instead of mate connector 2 breaking and mate connector 1 jumping over, mate connector 2 would be okay, right? But because it's tied to your location, right, if you ever change your selection from here to here, right, whatever you had here will never jump over here, even if that might otherwise be what a behavior you want. And so actually for finite queries like this, right, probably the best thing to do actually is to have two queries that aren't is actually have two query parameters, one for mounting hole location 1, one for mounting hole location 2, right? Because the user experience is pretty similar in that case. But you don't actually have to tie to the entity. You can still use the query because the query itself is somewhat stable, right? And so that way, if the user deselects the first one and changes it somewhere else, whatever they had will jump, and that will kind of, that's logically okay in that case, right? And so that's the same reason why this is limited to 1, right? Because that way, if someone makes a hat and adds something to it, and then later decides, I want to move it, right? Rather than getting a new hat based off of the underlying edge, right? The hat you get is unique to this feature. And so if you have something mated to this hat and you change the location, or you delete the sketch and then, resketch it and then, update this feature to point to the new one, your whatever you had made it to the hat will be okay. And so I think that's actually desirable. And so, but yeah, so that's why like, that's like something we have to think about as feature authors is like how things are going to behave as things as editor made, and things like that. So that's one part of it. Yeah, the other thing we have to think about is like what we're doing with the underlying sketches here. Yeah, so regardless of what we do need to stabilize our selections like that. And it's a little bit less bad for when you have a COTS like this, I suppose, because there's no like actual selections, so there's nothing to stabilize on, right? There's no underlying reference that the user has made. And so what I described with these locations really only matters for here, right? This hat. It doesn't matter for the other stuff. And so because of that, right, I actually am going to implement my suggestion of having 2 individual queries, right, rather than having 2 individual queries limited to 1 each, right? Location 1, definition of mounting location 2, right? And we can verify if we look at the fillet feature, first side face, second first mounting hole location, second mounting hole location. I'll do this. Second mounting location, right? And one nice thing with Onshape is when you have 2 max limit 1 selections in a row, right? When you make the first one, it'll automatically jump you to the second. Sorry, a little bit of bile there. Been a long day. Yeah, so it'll automatically jump you to the second, so the user experience is pretty good here. And I do see this is wrapping, which I don't love. So maybe I'll try to shorten that a little bit. To maybe just mounting location will suffice. And yeah, that's what I'm doing anyway, so that makes sense. Okay, perfect. So we'll do it like that. So that way, we do have the tying to the entity, right? So, if the user decides, oh, I don't want this location, I actually want this one, right? That way it's nice and explicit exactly what they're doing. Although the downside is like deselecting and stuff is a little more awkward now. But because we were limiting to 2 anyway, it makes it a little bit more explicit, which I like. So we'll give that a shot. And so I'll update some code for that now, right? Yeah. First mounting location. Location for the first mounting hole. Okay. Right. And then we'll map the array of definition.first mounting location, definition.second mounting location, right? And then we don't actually need, and then we don't actually need the identities here, right? because we're using the array, so we don't actually want to tie to the underlying location. So that way it will jump if you change your selection, which is the behavior we want, right? Yeah. So that's good. This will still be tied. And actually, that's true. So here we don't want the bearing edge either. For the same reason, if you change your bearing edge, it shouldn't matter. It should be able to just ride along, and that won't affect anything. So that helps. And then here we don't need identities, right? So and I'm realizing it is requiring you kind of to have identities implicitly. Although I know from how I coded this, I can just use, I could just pass an empty array. So I guess I'll go ahead and make that edit I wanted to do yesterday of updating this to take an array of circles. Okay, let's see that I did that correctly. Next, this will be the next. Oh wait, no, that can work. Yeah. Okay, and cur will be an identity now, which is fine. And that's all we need the circles for, which is fine. So yeah, cool. Okay. And so we can just pass this here now. Yeah, I think that's fine. Okay, and then we'll change this back. So we'll always sketch, we'll always sketch the two in order. Right, first mounting hole, second mounting hole, right? This will be location 0 and location 1. Mounting locations, right? Yeah. Those are 2D vectors. Yep. Okay, cool. So we're happy with that. Okay, and then the way we extrude these is going to be a little bit different, right? So I still want to extrude into the part normally. I'm happy with that. But I do want to extrude my hat normally. And because today is a little bit of a refactoring day, I guess I'll do some of that now. So let's start by grabbing this logic up here for my initial error handling. Yeah, so this can be our and that's a weak. Bearing edge, right? Context is context, definition is map, right? And this doesn't need to return anything, which is nice, right? Because there's no return value from this. I guess there is. I should probably return the scope, and maybe I need to return the whole face as well. Let's go check. Whole face, and I assume scope is also used somewhere. Yeah. Okay. Okay. So const result equals verify bearing edge, right? And then const whole face equals result dot whole face, right? And const scope equals result dot scope, right? And then I'll go return those values now, right? So this returns a map, and we'll return a map that looks like this, right? So whole face will be our whole face, of course, and our scope will be our scope, right? So just building a temporary map key with key values, whole face to whole face and the scope to the scope that we got up here, right? And then when we get up here, right, just grabbing that map and then dereferencing the two results into local variables. Okay, so that works. And do I actually need the whole face beyond? That does take the whole face. Okay. Wait. Oh, that's the only place it's used. Okay, so I could actually move this call down here as well. Right. And then, right, I can return the circle plane directly. Yeah. And so that I like, because then instead of having this, right, I can have the circle plane. Okay, so we're happy with that, right? So we'll do this block of code next, right? This needs to be var, right, because we modify it. Although it shouldn't need to be for much longer. So here we'll add a function to apply the angle manipulator, right? So we'll grab that logic and we'll call it function apply angle. Right, something like that. So then we just fill in the parameters we need. And by convention, anytime you have context, that always goes first. And then if you need an ID, you do ID. And then if you need a definition, or if you need the definition, you do definition. And then typically the word definition, if it's a map, typically by convention, that's like the name of the feature map you're getting, right? So that should be like all of your parameters. Although that doesn't always have to be the case. A lot of like Onshape standard library features, for example, will, modify that. And here actually I'll do if definition.scope, or what is it? Scope does not equal, no, it's not scope. Source. Oh, boo. Yeah, so I'll apply this logic here, right? And so here, right, all we do is skip it if our source is incorrect, right? And of course, you could also keep the original call and then just not call it if our source is wrong. That's entirely up to the user. Yeah, so then we'll just return the circle plane at the end here. And actually what we can do is we can put it in here, right? And then we don't even need this else here, right? If is query, right? We can return the circle plane. Right, so rather than checking if we do have a query, we run this code. If we don't have a query, we can just return immediately, right? So early returns are helpful, and then we can do it like this, right? And then we can throw an error at the end, right? So we can kind of flatten our structure a little bit, clean up our code that way as well, right? So that's one of the major benefits of like writing out, extracting out functions like that, is like sometimes by having your scopes and things, you can make the logic, besides like, you know, breaking out logical chunks and like keeping things nice and like contained, right? It makes it a lot easier to see your logic, and there can also be like code quality benefits as well, where you can like delete dot levels and things, right? So here now, right, it's pretty easy to see like, okay, this only runs if we're not a custom hat, right? Or if we have a custom hat, we're going to return. That makes sense, right? If we don't have an angle ref, we're not going to do anything. That also makes sense, right? And then we just check if we have a vertex or a line. And technically, we can even move this down here, right, for a little more performance, right? So if we have a vertex, we're going to, you know, do the vertex thing. If we have a line, we're going to do the line thing. Otherwise, we're going to throw an error, right? So the code flow becomes a lot easier to understand, right? And then when we're looking at the top level code too, right, we see, okay, we're going to verify the bearing edge. That gives us our circle planar scope, right? And then we're going to apply the angle reference, right? And so like as you break out these function calls, the code becomes a lot more readable too, right? So this I'm going to leave for now, but I do want to change that later as well, right? So here we have some more error handling, right? And then here, right, we can definitely break this out into its own function. And we need the definition here, and then we need a circle plane. Return this plane. Right, we don't even need to modify it there. Apply axis flips. Okay, sure. I'll keep that name, right? So now we do this part, and here, right, like, you know, that does that, but we really don't even need to, right? So we can do circle plane equals apply axis flips, right? Same thing, right? And then lastly, we have our angle stuff, right? And so once again, yeah, it probably makes sense to break that out as well. Context ID is ID. I do know we need an ID because we have a manipulator in this code that we're adding, right? And then we also need our circle plane, of course. Right, we can return this, right? We can convert this to an early return again. Right, to get rid of a dot level. Or a value there, and then here we need the width, which is presumably the width of that. I'm wondering how else we could do this. I guess I like it being together like this. Oh, and I'm going to throw a precondition on here. So you can have preconditions and functions. They don't do anything at runtime, but they can be useful to help guarantee semantics, and you can run them, and they do get checked in when you run like with the monitor. So you can define things somewhat more explicitly, because sometimes like the generic types are pretty vague, especially vector, you know, because like value is vector, right? A vector is just any non-empty array of numbers or lengths. semantically, right? And so there's a bunch of more specific functions you can run on vectors to clarify exactly what they are. So, a vector could be a 2D point, right? It could be a 2D direction. It could be a 3D length. It could be a 3D direction, right? It's not so clear. Or, you can clarify that way, which is helpful. So, yeah. And so here I want to assert that this is the top level ID. Because a fun fact about manipulators is they only work if that's the top level ID. So like, so anything like this, right? Or if this function is called with an ID that has an append, right? Or like any modifications like that, it won't work, which will be sad. Yeah. So, and then I will go ahead and take this, right? And again, like width is a value with units is another example, right? A value with units can be an angle, it can be area, it can be a length, right? And so you could do like, is length, right? Or is length? Yeah. So you could do like is length width, right? Although I personally think that's a little overkill because, the width should obviously be a length. We shouldn't really have a problem with that. Like the semantics of width is value with units, like it's pretty obvious that this is going to be a length, not an angular or, an area or anything goofy like that. But you never, it can be helpful to explicitly do that. Yeah. So then we'll go ahead and come up here, right? And we'll do our, so this is where we need to get the width there, right? And we can do our circle plane equals apply angle. Circle plane and width, right? Yeah, so to go off of what I was talking about a little bit more, right? Or I guess we're not quite there yet. But yeah, so like because it's checking the top level ID, right? If I run this with a static analysis, or if I was to analyze the feature or monitor like my robot bearing hat part studio now, it would go ahead and flag that this is wrong. Oops, that's profiling. I'll monitor my robot bearing hat. Right. So here you can see it's saying, actually it's just saying the width is undefined. That's funny. Because, because if it's a custom hat, then I won't have a width, but it doesn't usually matter because that will return out immediately. But that is funny. So maybe then I should lift these calls out. And just not do them at all in those cases. So that's actually something I didn't think about, right? But it is technically true, right? So we can see like how, like you can use the static analyzer to get like code results, which is cool. So we'll do that. Right. And then I'll do this as well. Right. Cool. Right. And now if I change this to a setting where it does hit the angle manipulator, right? Obviously I have errors, but here you can see it's going to fail. It's going to say it wants a top level ID, right? So that's how that's how you actually take advantage of preconditions and stuff. You do actually have to monitor a part studio. It's not enough to just like write them, because by default when you use a feature, like those things aren't checked for performance reasons, and because like if you flag it for a user, like the user's obviously not going to know how to fix it, so they just don't bother, right? Like if you have a type error, or, you're passing undefined when you should be passing like a valid units or whatever. Right, that generally isn't a showstopper, like in our case, right, where I was passing a width is undefined because it was custom length and it wasn't defined for that. The logic was still fine, so it won't crash the feature. But at the same time, as a feature author, when I can take advantage of that static analyzer to make sure that everything is consistent. Yeah. Okay, so let's see here now. Yep, so that's that. We don't need those guys anymore. Alright, we'll keep on cracking right along. So we've done that. I do want to get a function to get these guys, but let's do this. Okay. Ooh. Don't need this function here. I'm just playing with it so it looks a little more like this because I kind of like the semantics of this a little bit better. Yeah, so I guess I could throw this in a function as well. And this is a case where like having functions can be pretty helpful because like this pattern of like having to declare variables and then fill them in immediately is kind of goofy. Although, I don't know. And this way we don't have like the width variable hanging out undefined. Although it's not so clear. Yeah, because the problem is like you have a map that sometimes has bore values and then sometimes has width, right? And it's not really clear like when which case you're in normally, which I don't love. So I'm gonna leave that for now, and maybe I'll come back to it later once the logic's a little more established. Right. Yeah, and this gets that. You could think of this as separate logically from the above stuff as well. But like get hole diameter. Maybe we'll do that. Okay, apply angle reference, apply angle. Right, so context is context, ID is ID, definition is map, right, just kind of the standard order. And this is going to return a value with units, right? So we can do that, right? And so now we have a little list of code up here. And that makes it clear too, then, like we can see like, oh, like we don't actually need to do that right there, right? We do need to get the width because we're gonna use it down here. But I guess you could do this. I kind of hate that though. I'm not gonna lie. I don't know. But yeah, so we can do like hole diameter, right? Equals get hole diameter, right? So yeah, so you can kind of see, hopefully you can kind of see the benefits of that. And so here, right, so this could definitely be a function, right? Get mounting locations. Same thing, copy paste, right? And here, because we can just return this, right? Otherwise we return this, right? And again, we don't need the else because we're returning here, right? And then we need a definition, this map. We do need a context for the verification, right? And we need a width with units, right? Actually, I am wondering, so this width here is used only down here, right? So I'm wondering if we call this get custom mounting locations, right? And then it's imply that this is a custom hat, right? We don't even need this variable at that point, right? Returns array, right? And then we don't need width, right? And so here, right? So you could do something like this, right? Where you just call your function in one case and then you call this in the other, right? And if you wanted to take this one step further, you could write a function called get standard mounting locations that just takes width as a parameter and returns this array, right? So that'd be a very simple function. And then you could potentially just do that in line with like a ternary operator. So you get away from this var pattern entirely. But something like this I think is pretty reasonable as well. And so we don't even need the whole diameter at this point yet, so we can just keep on chugging that down here. Right, well I guess we'll just get it here, because we may as well. But yeah, so and like already, right, so like after just that little bit of refactoring, right, it's much easier to understand like, okay, like we're gonna verify the varying edge and get the circle plane and scope, right? Then we're gonna apply the angle reference if the user selected one, then we're gonna apply the axis flips, right? And then we're going to get the width and bore values, right? And then once we have that, we're gonna get the we're gonna apply the angle, right? Setting, right? So we can see the order that things are happening in, right? Then we get the whole diameter, and then we get the custom mounting locations, or if it's custom, always we get the mounting locations, right? And so like, you know, like already like it's way easier to read the logic, and like even if you don't know anything about this feature and like didn't know like any of the parameters, it's already pretty easy to like understand the overall logic and like the overall flow of things. So just by introducing a couple functions and like breaking out some of your code, it becomes a lot easier and a lot more readable, which is nice. So yeah. And so now, right, so here's a big function we can write. I'm going to write a, so we'll grab this, right? And here, right, this rotate manipulator. Can come up here. And I'm realizing this is probably more appropriate as rotate. Well, I'll rename it to angle manipulator. Okay, but yeah, so we can do our function model bearing hat, right? Hat, right? And so we'll paste all of this logic that we have so far, right? And again, so we can see we're probably going to need a context. This context, right? We're definitely gonna need an ID of some kind. So we can identify what we've created, and then we see we need probably the circle plane is plane, right? Probably the var values is map, and then probably the mounting locations is array, right? And do we need the whole diameter? Not yet, right? Cool. Right, and then we can return our queue created by, right? yeah, we'll return the query, right? And so this is a good point to talk about IDs, right? So here I had this hat ID, right? And I was passing it down everywhere here, right? So that creates my hat ID, right? And then I can extrude it. Extract faces, right? And then this returns a query for the face, right? So instead of having my hat ID down here, right, I can actually lift it out of this function, right? So instead of doing all of that, right, I can do it here, and then I can create my bearing hat, right? And if I pass my hat ID here, right, so this might be a little confusing, right? So far what I've been doing, right, is generally whatever the name of a parameter has been, right, that's what I've been passing, right? So like here, get bore values, this parameter, right, when I call get bore values, oops, I didn't want to go back. Right. So when I call it, actually not technically, but generally that's a pretty common pattern, right? So like here, the names of the parameters are context, ID, definition, circle, plane, and width, right? And that's exactly what I'm passing, right? But the truth is you don't have to do that, right? And the reason you don't have to do that is because functions, the parameters you define, right, really doesn't have any relationship to what people call it with, right? So for example, just because, this function defines a parameter named width as the 5th argument, right? I don't actually have to pass a variable named width or even a variable at all, right? So I could also just as easily do something like this, right? And, if you're used to, if you've done any sort of programming at all, you've probably realized by now, like, that's the exact same thing, like anytime you interact with like Onshape functions, right? So for example, this constructor here for vector, right, it takes an x and a y, right? And so that's just semantically, right, what it is. But you can pass whatever values you actually want here, right? It doesn't have to be a variable named x and a variable named y. And when you do get to that function, right, so to the function author, it doesn't matter what you've passed, right, what the name of the variable was, or if it was a literal, like a 1 times int or 2 times int, right? They just have their parameters, right? And so whatever values you pass gets copied and provided to that function. And so basically what all that means is, right, when we pass ID plus bearing hat to this function, right, inside this function it's still ID, right? Because that's what I've named this parameter, right? I could name this hat ID, right? And we could use it like that, but we don't really need to because it doesn't matter. It's just semantics, right? So when we take our ID, right, so because this function was called with hat ID, meaning hat ID plus bearing hat, or ID plus hat, right, anywhere I use ID inside here is going to still be ID plus hat, right? So then when we add something onto it, right, now we're getting ID plus hat plus connecting lines, ID plus hat plus connecting arcs, and so on, right? So the big difference, right, the reason why this matters is because IDs are hierarchical, right? So, when I pass ID plus connecting lines to sketch connecting lines, which is another of my functions, right? Again, we see the same pattern of taking ID, right? So whatever this function creates is going to be nested under that ID plus connecting lines umbrella, right? And moreover, it's going to be under this top level ID umbrella, right? And so when I want to get all of the edges created by these two functions, right, I can just call queryCreated by ID, right, and that will automatically traverse this tree that these IDs have umbrellaed off of, right, to get my edges, right. And so that's why ID matters and why Onshape even makes you provide it in the first place, right. is one, it like allows Onshape to like uniquely identify all the features in a tree, and it like guarantees that they have an order. But it's also really a really useful data structure for identifying the results of given operations, right? And so this, and then this ID here will return all of these, right? But moreover, because the ID passed here is ID plus hat, right? So inside this feature, all of these IDs are implicitly ID plus hat, ID plus hat, ID plus hat, right? So this will only return edges created by hat ID. So it'll always return these guys, but also means that it won't return any IDs, any edges created by something that's not a hat ID, right? So if we go back to the top level now, right? So as long as we're not using this hat ID to create any other edges before calling this function, right? So basically we can still use still use ID at the top level to make edges, right? Because these, like this edge here, for example, if I were to call this function and fill it out properly, right? This ID is under ID, which is the top level feature level ID, right? So the ID Onshape passed to our feature, right? And notably, this ID is different from ID plus bearing hat that we passed to create bearing hat, right? So when we go into create bearing hat, right, even though we're calling Q created by ID, right, it's actually implicitly hat ID, right? So it's not going to return the edges created by this other operation, right? So we've essentially segregated our operations, right? We've kind of created two separate trees, right? One which is ID plus bearing hat, and that's everything owned by create bearing hat, right? And then another that's ID plus spline through edges, and that's going to be everything that OP spline through edges does, right? So we've kind of created a layer of abstraction. So anyway, so all of that is a long way of saying, right, even though we're operating on an ID, right, it doesn't matter if this is the top level feature ID or some sub ID, right, bearing hat ID in this case. Our operations are segregated, and so like function calls like this, which would normally you'd be worried about accidentally grabbing other edges created by this feature. You don't actually have to worry about that, which is nice, right? So that's one of the big benefits of creating functions, right? Is it makes it clear like what those cut points are, and so then if I ever want to get my bearing hat in the future, right, I can just call like Q created by whatever ID I passed to bearing hat, right? Right. So it's really easy then to write a query like my bearing hat, right, or a query from my bearing hat is now going to be Q created by hat ID any type body, and I think I do need a filter for like body type solid, because otherwise I'll get like some edges and like splines and things. But this will be my one. This will resolve to a single part, which is created by hat ID, right? Because hat ID is used to generate the actual part, right? And so because our IDs are hierarchical, it will actually get that, right? Now, of course, I don't actually need to do that because I did code this to return a query for the hat, right? So it doesn't end up actually mattering, but it is kind of neat. Or it is good to know about that, right? And there definitely are times where you're doing lots of things or like, doing multiple operations. And so you can take advantage of that. Okay, so this will be create bearing hat. And I think I'll actually call this create bearing hat profile. Well, not profile really. Create bearing hat base, right? And that's because I don't actually want to cut the holes in this function because I'm lazy. So we're just going to do this, right? So this will just create the hat and extrude it. But it won't cut the holes. I'll do that in a separate function. And then I do want to clean up some of this angle stuff a little bit, right? So the ordering here is kind of important. I'll move this stuff down here. I'll keep reduce angle in the neighborhood because these are the functions that use it, right? So this logically, in my mind, this is reduce angle, right? And then my angle manipulator, which is added here and then updated here, right? So I've kind of grouped the logic together, which is nice. And here, right, this is kind of its own functional unit as well. So I'll just leave that at the bottom. But that's also very much tied to verify bearing edge, right? Because that's where that is being called, right? Get edge direction info. So I could also move that to here, but I like to separate Onshape's logic from my own, just like in the feature, because that's going to be a little more complicated than some of the other stuff going on in this feature. But yeah, so that's what we got so far. Okay, get custom mounting locations. Yep, create bearing hat base. Cool. Okay, so we'll keep on cracking on. Yeah, so this is our bearing hat now. So we'll do that. Okay, so we'll keep that. And then let's see what else we got here. So here we're sketching our mounting holes. So this seems like a pretty easy function to write as well. Or it seems like a pretty good candidate to be a function. Context, ID is ID, definition. This doesn't even take definition technically. It takes mounting locations. Oh, and actually, so here's a fun thing, right? This is the only place that hole diameter is used, right? If I'm not mistaken. Maybe I am mistaken. Let's check. Hole diameter, get hole diameter, yeah, and then it's used there. Yeah, so because of that, right, I can just go ahead and move this call to get hole diameter right in here, right? And I'll still do it first because semantics, right? So if I'm willing to take definition instead, I could just do it here. Although actually now that I think about it, maybe I don't want to, because I do like that this doesn't take hole diameter, or it doesn't take the entire definition. It just takes like a few actual pieces. So I'm okay with this. And I do want the location of hole diameter to be somewhat defined. So I'll just add the other parameters here, right? Cool. All right, and then I'll return a query for this as well. Return Q sketch region, ID plus sketch. And actually I can just use ID here, right? And I don't care about filtering error loops. Right, and so here again, right, I can just do ID plus sketch, right? It doesn't particularly matter. Yeah, so a nice simple function there. Okay. So I'll still get the hole diameter up here. Just because, you know, I want to apply the info before we get into like too heavy like things that can throw errors. So that way it's applied. Although I realize it doesn't really matter, but yeah, oh well. So we'll do holes, or sketch mounting holes, right? So that just works. And this will be, I'll just give it a sub ID so it's like referenced off. Cool. All right. Do I have a get Let me see here. I thought I had a utility for getting, yeah, bounding box length. Okay, so instead of doing this, I can just do const length equals get definition on scope. So that's just like my own personal utility there. You want, oh, yep, scope. All right, and technically I could move this call down into, oh no, width is used in lots of places. Wait, no, is scope used in lots of places? Yes, it's used in Boolean as well. Okay, so that's fine. Okay, cool. So then this will be ID, right? These will be our mounting hole sketch. Right, so we'll extrude that. Ooh, this direction was inverted. That would have been bad. That would have been confusing. Because the error would have been facing the right way, which is not what we want, of course. Yeah, and then I'll just do Q created by this. I don't need to actually filter for solid bodies then. Okay, we'll do that, and then I realized I defined my reconstruct op and then I never actually used it. That's funny. Right, because I'm no longer using this, so I don't actually need this. I can just call it again here, and that's fine. Okay. Cool. Yeah, because I commented that out as well, so I don't need that. Okay. And so this here, right, can be a function, right, that cuts the bearing holes. Definition is map, scope is query, right? Is query circle plane, I'll put first. There's plane. Okay, cool. Yeah, so that's that. And I won't return any queries because it just cuts them, so it doesn't matter. I don't need to return anything. All right, let's give that a call. Give it an ID. Cool. Yeah. Right, and so again, then like this can be simplified to ID because it's scoped now, right? So this is a case, like normally this would return all sorts of stuff because I haven't actually cleaned up yet at this point in the future. But because mounting holes is scoped, right, this will be only the, things created by this sub ID, which in this case will be this, right? This can just be extrude then, right? Because this is inside a function, so it's pretty clear what we're extruding at this point. Yeah, we can still check that. That's fine. Error ID plus extrude, right? So this all works, right? So, yeah. Cool. Cool. So, yep. Yeah, and the linchpin of that, right, is because I'm calling cut mounting holes with a sub ID, right? If I was just passing in an ID, right, then that queue created by ID would return, all sorts of other stuff that I wouldn't want. So I do have to be somewhat careful there. But yeah, that works basically. And then this will delete everything except the bearing hat, which is good. Yeah, and we'll leave that there as well. So now we can see, right, so our function behavior is essentially the same, or it's not essentially the same, it's the same, right, it hasn't changed, because I didn't make any mistakes, I think. Don't quote me on that. But it looks like I did everything correctly, right? Yeah, so, it works, right? That still works, right, or handling and flipping, right, which does nothing like this, but, you get the point, right? So, yeah. But if we look at the code now, right, so this is our main function now, right? So it's been greatly simplified, right? We can see, exactly what's happening in the order of operations, right? And it's made a lot clearer, some of the various dependencies and things between the features, right? So for example, we can see width is really only used, it's actually only used to get the circle plane and the mounting locations, right? Which does give me an idea, right? Because if that's the case, then I bet we could just do something like this. Where's bore values used? Down there. Yeah, so we definitely want to get bore values. Well, I think we can just do this. Let's see here. This requires the circle plane to be fully specified at this point. Right, and that dependency is made clear because we can see the circle plane has changed here, and that's used down here, right? If we think about it, right, we know we want to apply the angle probably and get this fully simplified. Although this does run only if it's not a custom hat, so this doesn't actually matter, right? And so that's something else that wouldn't be obvious if you weren't looking at the code like this, right? Or if it was how we had it before, right, at the start of the episode. So I'm going to move this up here and change this to mounting locations. Right, and these are constant, so we could just do this here. Hole diameter doesn't matter, that can happen whenever. Yeah, I mean, this could literally be down here if we wanted to. Yeah. So, and it could also be in here. Maybe it should be, actually. Let's just do that. Sketch mounting holes. Oh, I guess it forces me to take definition. Okay, I won't. Fine, you win. This needs, this uses 2 parameters. Because otherwise you could just pass definition at hole diameter and call that good, but yeah. And I realize const lookup hole diameter. It really should be returning definition, not hole diameter here. So that's a good catch, right? Because if you always return the lookup hole diameter, then the table is the source of truth, which is not what you want. Because if the user tries to override it, then they can't, which is no good. So yeah, that would be bad. Okay, locations will be like this. Cool. Right. And so here it's a little bit clearer that this doesn't actually matter. Yeah, and this could even be down here. Well, I guess we're using the width, so we'll leave it in there. Well, I don't like how this is just kind of shoved on here, but I guess it works. So if it works, it works. Because this isn't actually any modeling stuff. Yeah, okay. So we can do it like that, right? So I'm still not in love with this, but it's hard to get rid of this without going to like a full custom type. So the other way we could clean this up, right, is we could create a custom type that basically has the bore values, right? It would have like the mounting locations, and probably like the circle plane. So like, basically the intermediate modeling information we've been using, and like the hole diameter and stuff, right? And so then we could write a function, that gets that, and then, then all of these would just take that custom type, right? So like, bearing hat definition probably is what we call it, right? So rather than like passing around the definition, like all these various values, right, we'd just be passing around that single bearing hat definition, and it would have all the information we need to do our modeling. So while that is an option, it's, I think, overkill for something like this, because it's quite a bit of work to create the type and maintain it. Although it is simpler, I don't know. It does clarify the dependencies and things. For a simple feature like this, I don't think it's worth it. As tempting, or as fun as it is to do stuff like that, it just gets a little old. So, yeah. Okay, so let's do the other stuff we need to do now. So this I'm going to move up here, because I want to get the mounting hole sketch before we start modeling the bearing hat. Yeah, we'll leave that. Okay, so let's cut bearing hat holes now, right? Maybe I'll do this, actually. Bearing hat, oh well, definition. Hang on, okay. Let's just write the code in line for now, I guess. So we'll just keep doing the same thing we've been doing, where we write the code in line and then we add the function later. That way it's just a little bit easier and you're not like going back and forth and like adding or removing parameters and things, because that does get really old really fast. So yeah, so let's, so we need to sketch one more hole. We need to sketch the center boss hole, and actually we do need to sketch the, really we need to sketch both holes of the counter bore if we are going to do that. Otherwise we could call the Onshape hole standard library feature, and actually cut the hole using like the standard library. We could even do that for the mounting holes as well. So far I've just been sketching and extruding circles, which doesn't give you the hole attributes, but because they're simple holes, I don't personally think it's worth it, because there is a fair amount of overhead associated with the standard library hole feature, because that is equivalent to just using like the hole tool and like doing it like that, right? Which is kind of what we were talking about before. Although, yeah, that is maybe a little more, well, not robust, but through all, yeah. And then I could do my counter bore as well. Okay, you know what? Alright, I'll be lazy. I'll bite. Okay. So I am going to use the Onshape hole tool for our bearing hat. So this is the hole feature. And so by default, Onshape gives you the common import, so you do need to import individual holes if you're going to use them. Although I think I get it from my STD hole feature, which should export it. So, but otherwise you'd have to import it. And the way you do that is just find the hole. Or you just find whatever name it is, and that's the name of the library. I'm pretty sure it's hole.fs. Yeah. So you would just create an import like this. You just copy this, right? The first part of the path is always the same, and you just make this hole, right? And that will give you the hole feature, but I already get it from STD hole, like I said. Okay, OP extrude. Oh, not that far. Okay. All right. So the first thing, so we are going to call it. Oh, that's right. It does take sketch locations. So that is one of the annoying things, right? Is the whole feature itself actually takes sketch points, right? It doesn't take like 3D points in space or anything like that, which is what we've been operating with, right? And so like in the standard scope case, right? It's like when you're like doing like a standard hat or something, or like a COTS hat, right? There is no sketch point or thing to select here, right? So there's not actually a way to call the whole feature on it without sketching that point first. And if that sounds really annoying, it totally is, and it's not a great time. Although I believe I can use OP hole instead. So this is an option. But if you're gonna do this, I mean, it's just so overkill, right? Because like it does a bunch of stuff we don't need, basically. So yeah, I'm not gonna do that. I'm just gonna extrude it. Okay, so I'll sketch my center hole. So const. Although I am doing a counter bore, maybe I'll use OP hole for the center hole, and I'll just extrude my outer holes. So let's do that. OP extrude. So this will be our. I'm just gonna call this mounting holes. And I'll update this as well. Yeah. Because mounting hole sketch implies like the actual sketch, which isn't true. And although even technically, like, because these are technically just queries, it's like semantically, like, the query will resolve to the sketches of the mounting holes. But a query is just a list of instructions, not actually the entity until you evaluate it in the context of an entity. So it's useful to think of them as, whatever thing they're targeting. But, sometimes that isn't the case, like if it gets deleted or something. Or, within the context of a feature, like it can't get deleted because, features are atomic. But, it's, you can... especially with like external queries or like user-provided queries, it's helpful to keep that in mind. So this should just always be 0.25 inches, right? And yeah, I'll just do this. Yeah, because these are all scopes, so ID plus extrude, even though there is another ID plus extrude in this document. Again, because it's chained on, it's it's technically ID plus like cut mounting holes plus extrude. So it's not actually duplicate with this. And when I eventually put that in a function, then it will also have its own sub ID. So let's just check how that works. Oh, does not equal cods. Where is my... Oh. Oh? Wait, no, not that. What's happening? Throw a print line in there. Okay, it's extruding. Two faces. Oh, I'm just... Wait. What's happening? No, it's been there. Oh, it's getting cleaned up. That's right. Okay. Baha. Yeah. Because this is cleaning up everything except the hat. So when it's not extruded, it's not... they're getting cleaned up. That makes sense. All right, so there I did a debug, and then that made it a lot clearer exactly what was happening. Right. Okay, so those are facing the wrong way, as I suspected. So we'll flip these around, right? And then I need to, and then I will OP hole the main hole, right? ID plus bearing hole, right? Our line will be, dot origin, negative circle, plane dot direction, right? How that works? Origin direction. Yep. Is there a line constructor that takes a plane? No. That's sad. Okay. Yeah, so that, and then we have to do our whole definition. So the whole definition oh boy, what is this constructor? There's a map at the end here. Right, so it takes an array, and then it takes a map as well. Right, so that's fun. Let's see here. Whole position, reference, position, radius. What? Oh, well, yeah. Okay, so that's axis point. We don't need that. Goodness me. Up to next. Oh, axis point. Yeah, so we just need a bunch of axis points. That's fine. Position is 0 times meter, radius. Okay, so this is going to be our bore values dot. Okay, let's see what we got here. These APIs are always fun. So we're gonna start from this side. Oh no, it'll start on the big hole side. So it'll start with our C-bore diameter divided by 2, right? If I recall correctly. Right, and then we'll go out to 1/16 of an inch, or 0.6 times inch. I guess I'll start at 0 inch as well. And so it will be radius here, right? And then how does this work? Do I do another whole profile here with the Oh, did I actually do bore values at seaboard depth? I think I did. Yeah, I don't need that. I can just hard code it. But yeah, so outer diameter, seaboard diameter, bore diameter. Okay, so then we'll go down to bore diameter. Bore diameter, and then the rest of the plate. How thick are these? 0.125. Yeah, so this will be 0.125, and that will be like that, I think? Question mark? Right, what's the second argument? Value.profile size, value.profiles.radius equals 0 times meter. Is that saying it needs to have one with 0 meters radius as your start point? This is a bad idea. Matched hole profile. What the hell? Name. I can give it a name so I can query for it later. That is not helpful. Let's go look at the documentation. Okay. So it takes OP holes, targets, yeah. Okay. Can't pass targets. What is that error? Oh, maybe this is supposed to be like this? No. Operator for minus was not a number? What? What kind of goofy error is that? Okay, let's see what we got here. So, whole definition is profile, okay, and then you have a list of face names. Wait, really? Is it just bugged then? Wait. Optional parameters is, okay, face names. Wait, but that's just a string. Wait, what? This should be an array of strings, presumably, because there's an S here. This is actually just a bug. Let's take a look. Alright, we're looking at the freaking whole definition. God, it's so dubious. Give me the function, please. Okay, now it's, yeah, so here's the function. So face names is here. So this is string, right? If we look at the type, though, oh, and this passes an empty array, which results in that. Okay. Wait, but whole definition. So if we look at the type definition, right? So we can see face names is an array or it's undefined. So the documentation is just wrong, right? Yeah, so I could write a ticket if I wanted to, but I don't know if I care enough. But yeah, so this should just be array because it's a string. It's an array of strings. It's not a string. That's fine. It doesn't really matter. But that is kind of funny. Okay, so whole definition takes an array of profiles. And I keep saying see whole definition. Okay, so you take an array of whole profiles. Top to bottom, the final profile must have radius of 0. Must. and it collapses them automatically, which is cool. The final profile must have radius of 0. Okay, so yeah, so we are starting with this counter bore, and then I assume... See, the problem is I don't know if this does angled holes or not. I guess it does, right? It has to, because otherwise how would that work? So I guess I'll do it like this, right? And I'll add a tip just for them. And this, of course, needs to be probably more. 3/16, I guess. Let's try that. Okay, that works. Oh, yeah, that's a good point. Thank you, type checker. Right, so those errors are popping up because I am monitoring, right? So I am getting like the predicates and things running. So like putting your feature in a part studio and monitoring is actually probably not a bad way of doing development. I think that is what you're supposed to be doing, but people don't do it because it'd be like that sometimes. Which, yeah. What is that? Oh, that's the faces, right? Oh, that's because this is targeting my bearing hat, not that. And I assume this does need to be negative. I see it's still throwing. Okay, there we go. Right, so let's take a look at what we got here. Oh, ta-da! That's pretty neat. So then clearly my hat is too thick, which we can just fix real quick. Extrude. Cool. Okay. Ta-da! Bearing hat. Oh, and I need to boolean the holes as well. So I'll do that real quick. Okay. So we need to boolean these guys as well. Right. Unfortunately, we don't have to do nearly as much error handling with this. I type that body. This will be subtraction. Right. Tools, targets will be our bearing hat. Right. Okay, so primitive modeling, pretty standard. Yeah, so this ID is used here and down here, so that's a problem. We'll just call it cut holes, I guess. Right. And we don't need the debug anymore, of course. Okay. Cool, 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 cool. All right, ta-da, there is a bearing hat. Is it facing the right way? Yes, it is. Look at that. Wow, that's a bearing hat. So we're pretty chuffed with that. And then we can also do your standard hat, right? So we get that for free, and it does that, and it does that. And you can change your bore, and that works as well, right? So we are very pleased. Yeah, I don't know. It's a bearing hat. What can I say? Do I want to add a mate connector? I think I will. I will add a mate connector in the COTS case. So we'll do that real quick. Else OP mate connector. Right, this is pretty easy. ID mate connector scope, and then the coordinate system will be our circle plane coord system. Let's call that constructor. I guess I'll call it like this because I don't want to be weird. Right. Yeah. So we'll do that. Right. So when you get a COTS, Yep. Mm-hmm. Hello? I was expecting a bearing hole, or a mate connector. Oh, it's getting deleted, of course. Okay, so let's update this to delete everything that isn't a body. So const. Okay, so let's do this. Problem is, mate connector is both a body and a sheet. So maybe what I'll do is I'll delete mounting holes because those always get created, right? This will just be the const bearing hat, right? And then the other source of things in this is in here, right? So I'll just run a cleanup here. Right, and then we'll return bearing hat. So it's another OP delete operation, but I don't think it's actually that big of a deal. And we're missing a sketch because there is another sketch because we sketched the borehole itself. Okay, let's do that. So clean up here. I guess I can just clean it up. Wait, really? Where's the sketch? Oh, it's those. Wait, no, but I'm deleting those. Oh, that's the sketch region. Yeah. Okay, we'll just delete all the sketch stuff. Okay. Yeah. So normally just deleting all your sketches would be sufficient. The only caveat is because we're also deleting ooh, that's awkward. Can we just invert the plane direction? So I see my z-axis is facing the wrong way, right? It should be facing outwards, because that's kind of the standard for holes, which we don't want. But the problem is, it's kind of unpleasant. So I wonder if we could just define this as, we just do this. I think that will take care of it for us, actually. And then, so that just inverts the entire definition, or that just reverses the direction, right? So it's less than or equal to, I change it to greater than, on whether or not it needs a flip. So I will flip it to be facing outwards. And then I just go through and I find all of my normal, and I add or remove a negative sign. So the Z will now face out from the center. That one doesn't matter. And actually, oh yeah, I can't, parallel vectors doesn't work there. That's good. This one doesn't matter because that just flips it. This one matters. And then the mounting holes will go inwards, right? And this will go, cutting them, we will extrude inwards as well. Yeah. And the axis will face inwards, I guess. I don't think it actually matters. It shouldn't matter. We can just, it's arbitrary. Yeah, then we'll rotate around that. Okay, cool. All right, ta-da. Actually, I do wonder if the axis being backwards is a little weird. That's the default mode. Wait. Yeah, default is like that. Is that goofy? Oh, that's weird. Wait. Oh, it's because I have a... No, that makes sense. Yeah. Okay. Cool. So that works. And we can set that to 0 again, and that is all fine. And that still works. Right. So yeah. Cool. Nice. All right, and you can specify your angle reference, and that makes things particularly weird, but you get the idea. Oh. Hold the phone. Oh, because it's rotate 90 from that. Yeah. Okay. Cool. So yeah, that makes logical sense. So you can, do all of your angle reference things that you could possibly want. You get the make connector. Should there be an option to not have the make connector? I don't think so. I think we'll include it. Yeah. And so there you go. There's your bearing hat feature. Do I need to do anything else here? Let's see here. I already did that. Cut holes for mounting bearing hats. Yep. Source. Okay. I guess I'll just do another read through of the code, make sure everything is the way I want it. Width and bore is fine. Bore table, sure. Hole fit table, yeah. Enum. I'll put this enum up higher. I guess one thing I can do is I can do some predicates for the UI. Actually, I think I will do that. So the way predicates work, right? So I'll do an angle reference predicate. Right. So you can also use predicates in your normal code. So a predicate, nominally a predicate is a function that returns a Boolean, right? So function returns Boolean is equivalent to a predicate, although predicates are a little more simple than functions because they actually just consist of a list of statements. So like a simple predicate example is you can do stuff like is COTS bearing, right? And so this is actually a somewhat common pattern. And then all you have to do is do like definition dot source equals source dot COTS, right? So now that this predicate is defined, right, instead of doing like here, right, you could do is custom is COTS bearing, right? So that's equivalent, right? And this is valid also in your code as well, right? So you could even use it down here. So all these places where I'm doing equals custom hat, you could use that predicate instead, right? I don't do that just because it's a little work to define them. If you're like renaming things or whatever, it can get kind of annoying. So for small features like this, I don't think it's generally worth it. But yeah, so that's what a predicate is. And then you can also put multiple statements in here. And if you do that, then it will become like an and, right? So if you do this, or it expects, it only returns true when everything is true. So this will never be true because it's not possible for the source to be COTS and a standard hat. But you can do your conditionals and whatnot. So generally, like semantically, like a predicate like this is intended to be like used inside if statements, basically, like conditionals, for like control flow. So that's a normal predicate, right? And then there's also UI predicates. And so UI predicates, right? The standard is to always include the word predicate in the name. And then the spec is you have to take the definition as the first argument, right? And then what this does is it's equivalent to just putting in here, right? So instead of having the angle reference, right, I can just call my preference now, right? And this is exactly equivalent to having those this code in here. I'll just call it angle predicate, I guess. We'll call it, angle reference predicate, right? Source equals dot COTS. Does not equal dot custom hat, right? So that's exactly equivalent. So it does the exact same thing for UI as functions do, right? It allows you to break out various bits of code and have it more in mind, which is helpful sometimes. But yeah, we'll do some light renaming. I don't like the name of source, so I will probably rename that to hat type. Hat type.cots, hat type.standard, hat type.custom. Method? Bearing type? Those are always the big questions. You spend all your time on. Maybe hat type. Hat type.cots, hat type.standard hat, hat type.custom hat. That seems reasonable. So I'll throw on case sensitive and replace all, right? And then I'll do this, and I'll rename source to hat type as well, right? I think I want to rename standard hat to just standard as well. Well, I never checked that. That's funny. Because it's always just whether it's custom hat or not. And this will just be custom. Okay. And so if I am checking custom 5, COTS 3, okay, that's about right. That's fine. Well, I guess you could just do, maybe I'll write one predicate is COTS. We'll do it like this, is COTS hat. Definition is map, right? And then so we can do that, and then we can also do does not equal, and we can do the inverse as well. And then there's also, I guess we need to do the is custom hat as well. Oops, I replaced the logic as well. use custom hat. Okay, and then we can also look for the inverse. Okay, cool. Yeah, so apply angle reference, apply angle offset. Okay, that makes sense. Get this button real quick. Okay. Cool. Blah, blah, blah. Alright. Alright, so we did that. Yeah, so, you know, just a little bit more syntactically precise, or, well, I don't know, less verbose, I guess, than typing that out. Especially, you know, for simple stuff like this, it probably doesn't matter, but I guess as a demonstration, it's helpful. And then, yeah, that's about right. Circle plane. Okay, cool. I am pretty happy with that. So, yeah, I don't know. I'm satisfied. I can't believe I actually need to call. I can't believe that's still, is that still required? I'm actually curious. It is. Wow, that's so strange. And I say that because I know the whole tool supports not having a tip now, right? They added the end angle, right? Did they? I thought they did. Wasn't that like a whole thing? Am I tripping? Drilled? Maybe they didn't. An undercut, a chamfer? I guess I'm just misremembering. I could have sworn. What kind of fever dream? Okay. Now I'm confused. Maybe for tadpoles or something? I could have sworn they added a bottom option so you could make flat holes. This document might also be on an old version of the standard library. Let's go check, I guess. Well, okay, let's just check the source code, I guess. Hole. Okay. Termination. No, that's that. Yeah, tip angle style. Yeah, so you can use a tip angle. So that begs the question. If you can set a tip angle, then how come their OP hole API does not support it? It does raise some questions. Yeah. Very surprising. I wonder if profiles. Seaboard depth, seaboard radius. That returns face types. And then... Okay, this is just turned into me looking at standard library code again. Although I'm curious still. Where is this called? Oh, goodness me. No. Okay, face types. And then, yeah, profiles are used for the whole definition. And they call OP whole. Very strange, very strange. I assume maybe, if I had to guess, they're deleting the tip manually afterwards or something crazy like that. Which is kind of wild when you think about it. Maybe I'm wrong, though. Maybe I'm just, like, not understanding the documentation of OP whole or something. But it does pretty clearly say the last one has to be 0. So, yeah. Positioned or matched, yeah? Yeah. Very strange. Very strange. Yeah. Okay. Anyway, it is what it is. But yeah, so that's this feature script. So this has been an overview of my development process for making a new feature. Yeah, we've gone through it. I think this feature is, practically speaking, it's relatively simple, right? Although we do have quite a few options in here, quite a few behaviors and things implemented, right? And then, and we can do, all the various things we'd want, right? Error handling and all that good stuff, which is nice. So hopefully people will find this useful. And yeah, we can go over, do we want to do, no, I won't. I could, technically it doesn't have to, we could still create the bearing if there's no mounting selected, but life's too short. But yeah, so I guess just to close the loop on the robustness stuff I was talking about, right? So if I add a make connector here and here, right? So by doing it this way, right? So if we were just stabilizing, I'm using this normal stabilization technique, right? Then, 1 and 1, so when you delete this first one, right, you expect it to break. But instead what happens is, okay, let me select, please. Hello, Onshape? Hello? Can I, what? Was it bugging? Okay. Yeah, so if I were stabilizing, right, when I deselect, 1 would break and 2 would be the same. But then when I reselect over here, because this is a different underlying identity, right, 1 would be broken still, but 2 would still be okay. So instead, when I reselect, because it's tied to this location, it's okay. And so I can still shuffle them by, reorganizing like this. And what is happening today? Why is it wigging the heck out? So I can still reshuffle them like that, right? And 1 will end up over here and 2 will end up over here. But at least it's now a very explicit behavior, rather than like something that just kind of weirdly happens. So it's just a little more explicit now by having the explicit entities, as opposed to a single query limited to 2. But maybe that's just, yeah, I don't know. I think it's better, but maybe I'm wrong. I could definitely see an argument for just changing it back to the way it was and just doing the stabilization thing, because that is also very reasonable. But I think if you are going to limit it to a finite number of selections, like 2, I don't know. Doing it this way isn't necessarily the worst thing in the world. Why was I not able to select those points there? That was so weird. Let's see here. I was doing like this, and then maybe I'm just like really tired and I'm missing it. I don't know. I'll have to watch the footage again. Okay. Anyway, yeah. So this was my first time doing this ever. So, you know, hopefully it wasn't just me staring at the standard library and talking gibberish, you know, for 8 hours or however long this took. Probably about that long, if we're being completely honest. But you know, hopefully this was helpful. You know, even, yeah, and, you know, maybe hopefully you learned something, and you weren't just completely bored out of your mind by watching me rant and rave and go on and on about, you know, various things. But yeah, this is the feature. So this would be public, and I should have links to the code and everything in the descriptions of all the videos as well, as I've been going through it, so you could follow along at home as well. But yeah, this has been fun. And if you know, did find this helpful, or, you know, did really like it, let me know on the forums or on Chief Delphi, and maybe I'll do this again in the future. Yeah. All right. Thanks for watching.